Direct current problem solving skills. Video 2. Problem. A circuit diagram is given on the right with values of electromotive forces E sub 1, E sub 2, E sub 3, E sub 4, and resistors R sub 1, R sub 2, R sub 3, R sub 4, being shown on the circuit diagram. A. Find the intensities of electric currents I sub 1, I sub 2, I sub 3, I sub 4, and their directions. B. Find the electric charge stored in the capacitor C. Assume that directions of currents are as shown on the circuit diagram. For example, I sub 1 flows from right to left. Because the current passing through the capacitor is 0, the capacitor is temporarily removed from the circuit diagram for the ease of calculation. The circuit diagram includes 3 circuit plots, marked as Circuit Plot 1, Circuit Plot 2, and Circuit Plot 3. All their electric potential investigation directions are counterclockwise. For the Circuit Plot 1, the electric potential balance equation in the counterclockwise direction is as follows. E sub 1 plus E sub 2 equals I sub 1 R sub 1 plus I sub 2 R sub 2, which is equivalent to 3 I sub 1 plus 7 I sub 2 equals 12 volts plus 21 volts equals 33 volts, which is equivalent to I sub 2 equals 33 minus 3 I sub 1 over 7. Let the above equation be equation 1. For the Circuit Plot 2, the electric potential balance equation in the counterclockwise direction is as follows. Negative E sub 2 minus E sub 3 equals negative I sub 2 R sub 2 minus I sub 3 R sub 3, which is equivalent to 7 I sub 2 plus 4 I sub 3 equals 21 volts plus 4 volts equals 25 volts, which is equivalent to I sub 3 equals 25 minus 7 I sub 2 over 4 equals 1 over 4 times, open bracket, 25 minus 7 times 33 minus 3 I sub 1 over 7, close bracket, equals 3 I sub 1 minus 8 over 4. Let the above equation be equation 2. For the Circuit Plot 2, the electric potential balance equation in the counterclockwise direction is as follows. E sub 3 plus E sub 4 equals I sub 3 R sub 3 plus I sub 4 R sub 4, which is equivalent to, for I sub 3 plus 5 I sub 4 equals 4 volts plus 10 volts equals 14 volts, which is equivalent to I sub 4 equals 14 minus 4 I sub 3 over 5 equals 1 over 5 times, open bracket, 14 minus 4 times 3 I sub 1 minus 8 over 4, close bracket, equals 22 minus 3 I sub 1 over 5. Let the above equation be equation 3. The circuit AD is just an electric conductor. The electric current balance equation for this electric conductor is as follows. I sub 1 plus I sub 3 equals I sub 2 plus I sub 4. By substituting I sub 2, I sub 3, and I sub 4 by the expressions obtained in equation 1, equation 2, and equation 3 respectively, the following equation is obtained. I sub 1 plus 3 I sub 1 minus 8 over 4 equals 33 minus 3 I sub 1 over 7, plus 22 minus 3 I sub 1 over 5. By multiplying both sides of the above equation by 140, the following equation is obtained. 140 I sub 1, plus 35 times, open bracket, 3 I sub 1 minus 8, close bracket, equals 20 times, open bracket, 33 minus 3 I sub 1, close bracket, plus 28 times, open bracket, 22 minus 3 I sub 1, close bracket, which is equivalent to, open bracket, 140 plus 105 plus 60 plus 84, close bracket, times, I sub 1 equals 660 plus 600. 16 plus 280, which is equivalent to 389 I sub 1 equals 1556, which is equivalent to I sub 1 equals 4. By substituting I sub 1 in equation 1 by 4, the following result is obtained. I sub 2 equals 33 minus 3 I sub 1 over 7 equals 33 minus 3 times 4 over 7 equals 21 over 7 equals 3. By substituting I sub 1 in equation 2 by 4, the following result is obtained. I sub 3 equals 3 I sub 1 equals 8 over 4 equals 3 times 4 minus 8 over 4 equals 4 over 4 equals 1. By substituting I sub 1 in equation 3 by 4, the following result is obtained. I sub 4 equals 22 minus 3 I sub 1 over 5 equals 22 minus 3 times 4 over 5 equals 10 over 5 equals 2. So, the answers to the current intensities are as follows. I sub 1 equals 4 amperes, I sub 2 equals 3 amperes, and I sub 4 equals 2 amperes. All of these four values are positive. This means the selected directions of all these electric currents are correct. In other words, in reality, I sub 1 and I sub 3 flow from right to left, meanwhile, I sub 2 and I sub 4 flow from left to right. Now, return to the capacitor C. To calculate the electric charge stored in the capacitor, the voltage between M and N, or U sub Mn, must be determined. To calculate U sub Mn, let's investigate the electric potential variation along both the circuit MKGN and the circuit MJHN. The electric potential variation investigated along the circuit MKGN is as follows. U sub Mn equals phi sub n minus phi sub m equals E sub 3 minus I sub 2 R sub 2 equals 4 volts minus 3 amperes times 7 ohms equals negative 17 volts. The electric potential variation investigated along the circuit MJHN is as follows. U sub Mn equals phi sub n minus phi sub m equals I sub 3 R sub 3 minus E sub 2 equals 1 ampere times 4 ohms minus 21 volts equals negative 17 volts. Both ways of investigation produced the same result. U sub Mn equals negative 17 volts. So, the electric charge stored in the capacitor is Q equals C times U sub Mn equals 10 times 10 raised to the power of negative 6 farads times 17 volts equals 1.7 times 10 raised to the power of negative 4 coulombs.